Good morning, good morning, good morning, good morning. Calling on all grade 12 maths fundis. Failing which, if there's no one, then I will be happy to do any other grade. Okay guys, I'm a bit late. This session was supposed to start at 5, but unfortunately I couldn't wake up early enough so that I could start the session at 5. So I'm starting the session now with the intention that it will end at 6:30. So any grade 12 learner that is possibly able to join this live, today we are actually going to look at the grade 12 trigonometry. We are going to specifically look at that's fine that you are going to school. Remember that after I do the sessions, I upload them to my YouTube channel. So if you miss the session, then not to worry. You can make sure that you subscribe to my YouTube channel. The bio is in the link. So the link is in the bio. The bio is in the link. The link is in the bio. You can go to my bio. There's a YouTube channel. It's called MathsIsAGame 5 to 7. And all the sessions that I do here live, I upload them onto the YouTube channel so that people can watch them when they have the time. So if you're going to school, I understand, that's fine. Prepare to go to school, no problem. But just remember that you can always find the session on the YouTube channel. So today I'm going to do double angles. I've already done 2 sessions already. Those 2 sessions for the grade 12 trigonometry are on my YouTube channel. You can check them out when you have time. They are very long, 1 hour and a bit for the grade 12s. There's even a playlist on my YouTube channel for the grade 12. So if you want to check out all the other videos that I've done for term 1, meaning your sequence and series, your inverse operations, and also your trigonometry, which I'm busy with now, you can always go onto the YouTube channel. You should be able to find those sessions uploaded on there. Okay, so today I'm going to do double angles. Okay, specifically we're going to look at double angles. So on the formula sheet, guys, again, on your grade 12 formula sheet, you have these double angles listed for you for your use. So the first double angle identity is sine of 2a. Remember, A stands for an angle that is unknown. Okay? Yeah. So the double angle expression of sine of 2a is equal to 2 sine a times cos a. Okay? Then there's the double angle for cos 2a. Okay? And there are 3 of these expressions or expansions for cos 2a. The first one is cos squared a minus sine squared a, which is not to be confused with the square identity that you guys learned in grade 11, because that one is sine squared a plus cos squared a. So that is not to be confused with that. This one is the difference of cos squared a minus sine squared a. That's the expression or the expansion of cos of 2a. Or alternatively, you can also express cos of double angle a as 1 minus 2 sine squared a. Or failure to use this one can also lead to 2 cos squared a minus 1. So these expansions are all contained on your formula sheet. So in the event that you forget these, you can always consult your formula sheet. They are there, guys. Okay? One has not to worry whenever they are writing the expansion of the double angle of sine and the double angle of cos. So these are very important, and it is important for you to note them. Okay? So I hope all of us are aware of these expansions, because they are the double angles of sine and the double angle of cos, respectively. Okay. So now we are going to look at some examples around these expansions so that we can become more familiar in using these expansions. And we are going to start smack bang in the basics. Say now we are told to write each of the following. Write each of the following as a single trigonometric ratio. Okay. I was asked to write each of the following as a single trigonometric ratio. So let's look at an example. Let's say we were asked to write cos squared alpha minus sine squared alpha. We are asked to write this as a single trigonometric ratio. So what would this be equal to? Okay, so when we look at this, we go back to our double angle expressions. We know that the double angle of sine is actually 2 sine a cos a, and then the double angle of cos has these 3 possible expansions. So now we are asked to write this here as a single trigonometric ratio. So what would cos squared alpha minus sine squared alpha be equal to? Anyone in the comment section would tell me what would cos squared alpha minus sine squared alpha be equal to, if you are looking at what you have on this expansion. So cos squared alpha minus sine squared alpha, if you guys look at this here, this mirrors that. So therefore the answer would be, okay, this is alpha, not x. So therefore we are going to say cos 2 alpha. Okay, and that would be our answer. because we are asked to write each of the following as a single trigonometric ratio. So it would be cos 2 alpha b. Let's say we are given 2 sine x cos x, and we are asked to write this as a single trigonometric ratio. Okay, so if we look at this, we go back to our formula sheet. Some of us may forget, right? This mirrors that exactly. Do you see that? Okay, there's a 2 there, there's a 2 there. There's a sine, there's a sine. There's an a here, but obviously that a represents an unknown. There's an x here, there's a cos a, there's a cos x. So therefore the single trigonometric ratio would be the reduced double angle. That would be the double angle sine 2, but then instead of a we write x. Okay, so obviously we write the variable that is listed in the problem. Okay, moving right along, let's look at another example. 1 minus 2 sine squared alpha. What would be the single trigonometric ratio of 1 minus 2 sine squared theta? Okay, so once again, when we look at this, we go back to our expressions, our double angle expressions. Which one does this mirror? It reminds us of the double angle of cos, because 1 minus 2 sine squared a is equal to cos 2a. Therefore, we're going to say cos of 2 theta is equal to 1 minus 2 sine squared theta. So therefore, this is the single trigonometric ratio. Okay. So I'm hoping you guys can see and you're becoming more familiar. You're like, oh, okay. So we see what is happening here. Yeah, 2 cos squared p minus 1. So once again, this one mimics this particular expression. 2 cos squared a minus 1 is cos 2a. So therefore, it is cos 2p. Okay. Here we have 2 sine theta over 4, cos theta over 4. So this here, we need to write it as a single trigonometric ratio. So then what do we do with this one? 2 sine theta over 4 times cos theta over 4. So once again, this, it reminds us of this double angle. Okay. So therefore what we do is we're going to say sine 2, but then what's located here? It is theta over 4. Okay. Then we obviously simplify. What's 2 times theta over 4? This 2 goes into 4 how many times? 2 times. So that means we have sine theta over 2. That is our answer. Because we simplify this. 2 times theta over 4 gives us theta over 2. Remember, this 2 is regarded being in the numerator. This 4 is regarded being in the denominator. So 2 times theta over 4. 2 goes into 4 how many times? 2 times. So that's why the answer is sine theta over 2. What about 1 minus 2 sine squared 5 alpha? Okay, so once again, when we look at this, it mirrors which double angle? Okay, it reminds us of the double angle of cos. Okay, but then the only thing we have there is 5 alpha. So that means we are going to write cos of 2 times 5 alpha. Okay. Or someone else could have written it as cos 2 5 alpha. That's also fine. Okay. Remember, brackets mean multiply in mathematics. Okay. So this and that mean the same thing. It's just that here I decided to put times, there I decided to put brackets. Okay, so then the final answer is, what's 2 times 5? That's cos of 10 alpha. Okay, so that is my single trigonometric ratio. Okay, let's go. We're not done. Let's go. Next one. Cos squared of 11 minus sine squared of 11. If we look at this expansion, cos squared 11 minus sine squared 11. Okay, so like I said, guys, this may look like we have the identity that we learned in grade 11, but this is not it. Okay, this is the double angle expression. Okay, because there's the difference, and we're starting with cos squared 11 minus sine squared 11. So therefore, the double angle of cos is what is listed here. So we write it as cos 2 times 11. But then we know what 2 times 11 is. 2 times 11 is 22. So therefore we have cos of 22 degrees. Okay. Let's look at another one. Cos 5 degrees sine 5 degrees. So this here, okay, looks familiar, but the only thing is that we have cos 5 first, followed by sine 5 second. So obviously we know that if it was 2 sine 5 cos 5, this now has the image that we are familiar with. So this is a matter of rearranging, because remember that when we're looking at the formula sheet, we're looking at the product of sine 5 and cos 5, right? And since multiplication, guys, is commutative, okay, the order in which I place these does not matter. So I'm going to say sine 5 times cos 5, okay? And then obviously this is the double angle of sine. So I say sine 2 times 5 degrees, which then obviously gives me sine of 10 degrees. Okay. Now this might look very tardy and you guys are like, but sir, you're doing simple stuff. The reason why I'm doing that is because it's important for us to become familiar with these, because what you want is to actually make the use of double angles and expressing double angles in their reduced form, from their expansion to reduced, or from reduced to their expansion. You want to be able to become familiar so that it becomes second nature. Because when you do complex problems, the basics, guys, are so important and are so fundamental. So here we have 2 cos squared 35 degrees minus 1. What is that equal to? So that means we are going to have, if you look at this, this is the double angle of what? Of cos. Okay? It mirrors cos of this, right? So we remember that. But obviously in our answer, we're not going to write that. Okay, this is just something to note, that it mirrors that. So therefore we write cos of 2 what? 2 times 35 degrees. And then our final answer is cos 70 degrees. So that's a single trigonometric ratio. Okay. Right. Now let's move on to something else. Let's say they asked us to calculate. Okay, we're still within the range of double angles. Calculate the following without the use of a calculator. Without the use of a calculator. Okay, so let's go. So we are asked here to calculate the following without the use of a calculator. Remember, guys, when they say calculate something without the use of a calculator, doesn't necessarily mean you cannot use a calculator. It's just that you need to show the steps of how you were able to get the answer. What they want is, they don't want you to take that particular thing and put it in your calculator first off and just write the answer. They want to see steps. So let's see what we have here. 2 sine 22,5 times cos 22,5. They're saying calculate the following without the use of a calculator. So what we have here is 2 sine 22,5 times cos 22,5. What is this, guys? This is the expansion of the double angle. So therefore, since it's the double angle expansion, we need to reduce it, obviously, to the single trigonometric ratio, which gives us what? So definitely, it's sine of 2 22,5 degrees. Then of course, what does that 2 times 22,5 give us? It gives us sine of 45 degrees. And then of course, we know that sine of 45 degrees, this is what we refer to as a special angle. Okay, so at this point we're more than welcome to grab your calculator and actually write the ratio that you get, which is root 2 over 2. Okay, and that is 100% fine. So if I grab my calculator at this stage and I use it, alright, because I've forgotten those special triangles that you used to draw in grade 10. Remember that for the grade 11s and the grade 10s, you can simply, when you see the special angle and it's actually acute, 30, 60, 45, you just grab your calculator and you write down the answer that you get. So it's fine at this stage to utilize your calculator, because like I said, just because they said calculate the following without the use of a calculator, this simply means they need to see these steps: the expansion, reduction of the double angle, the multiplication of the two angles, the special angle that results, and then at this stage you can use your calculator to get the answer if you have forgotten those expansions. Doesn't really matter. Okay, let's go on to the next one. Cos squared 22,5 degrees minus sine squared 22,5 5 degrees. Where does this lead us? I'm hoping as you guys are looking at this, that some of you are actually obviously doing these on your own. I can see, for instance, Mzo Kondlo, the Imbongi, is actually obviously answering in the comment section, but I would hope that some of you are actually just having your book open and you're writing down what needs to be written down in order to be able to decipher what you think is there. So once again, cos squared 22,5 degrees minus sine squared 22,5 degrees. This is the double angle of what? Of cos, because cos squared A minus sine squared A. So therefore we say cos of 2, 22,5 degrees. That's the double angle. Then the multiplication of 2 times 22,5, that is cos of 45 degrees. But this here, 45 degrees is a special angle. So therefore you write the ratio, which is root 2 over 2. Okay. That was nice and simple. Next up, number 3. Sine squared 15 degrees minus cos squared 15 degrees. Now we look at this and we're like, okay, this is not in that form where we have cos squared starting, followed by sine squared following, but there's a minus sign in between. So therefore that means, okay, this is not what it should be. And here's another thing. We know that 1 minus 2 is not the same thing as 2 minus 1. So there's no way that we can just force this thing and say this is cos squared of this is the double angle of the identity. So therefore, if we come here, guys, all right, 1 minus 2 is not the same thing as 2 minus 1. So I'm sure you guys can see that sine squared 15 minus cos squared 15, there's some sort of algebraic manipulation that we need to apply first here that has to do with something we learned in grade 10, something that we refer to as the sign change rule. What was the sign change rule? If you can remember and reflect back on earlier grades, this was when we were factorizing. When we would factorize, there was something that we would apply called the sign change rule. And it applied specifically to when, for instance, we have b minus a, and we would like to actually make the order to become a minus b. What we would do, we would take out a negative sign so that we can ensure that this expression, which is b minus a, retains its integrity. But then we swap around the a and the b. So in other words, if you take out a negative sign, that allows you to change the order of the b and the a. Look at this. If I take out a negative, the negative distributed back to the a gives me back the negative a, because a negative times a positive is a negative, and the negative distributed to the negative b gives me a positive b. So here I am going to apply this thing that we refer to as the SCR. It's like a procedure we apply, like CPR for doctors. Okay, when people are out of, like they don't have sufficient oxygen, we apply CPR. Here we are going to apply the SCR, because the b minus a that we see here, we know we'd like to have a minus b, so we take out a negative sign. So you change the sign externally to a negative that allows you to change the order. But this only applies, guys, when there is a what? When there's a negative sign between two terms. So look at this. Sine squared 15 minus cos squared 15. There's a negative sign in between. So what do? We take out a negative sign. Then we write cos squared 15 degrees minus sine squared 15 degrees. So hopefully we get that. And we understand why we did that. So yes, in trig, we still have to apply some of the procedures we've learned in earlier grades, okay? And algebra is not something that we put aside when we are doing our trigonometry. Now we have minus, What's cos squared 15 minus sine squared 15? That is the double angle expression of what? Cos 2 15 degrees. Okay, right? Then what is cos 2 15 degrees? That is cos of 30 degrees. But it's negative. So I take the negative, I distribute into the bracket. That gives me negative cos of what? Of 30 degrees. Now I can actually go ahead and utilize my calculator, because I can clearly see that this is what? This is a special angle. So at this stage, even though they said calculate the following without using the calculator, I can actually do that. Okay, so the answer, yes, is minus root 3 over 2. Okay, and there it is, guys. Do you see? So please, guys, we must utilize this sign change rule aspect whenever we are looking at certain other problems, especially when it is with regards to the expansion of the double angle. And we can clearly see that this is similar to something that we know, but it's just that this is positive and this one is negative. So we apply the sign change rule, take out a negative sign, change the order, cos squared 15 minus sine squared 15. This is the double angle of cos, so there it is. We then obviously simplify it, then we take the negative sign, we multiply it with cos 30, we get negative cos 30 degrees. This is the special angle. We then write the ratio, negative root 3 over 2. Okay, hopefully you can see how nice, simple, and easy that was. Guys, just hang on tight a little bit here. I just need to attend to something. Give me 10 seconds. Okay, I'm back. Okay. So we got another one. Cos squared 22, 5 degrees plus sine squared 22, 5 degrees. So when you look at this, cos squared 22, 5 plus sine squared 22, 5. So this here, guys, if you know your trigonometry very well, then you will see that this one is not the double angle. Rather, this here is what we refer to. Remember, addition is commutative. The order doesn't really matter if you have addition. But obviously, sine squared 22, 5 plus cos squared 22, 5. This is the square identity that we learned in grade 11. Sine squared theta plus cos squared theta is equal to what? To 1. So in Fupi, you are spot on, my man. This here is equal to 1. Okay, because it mirrors the square identity that you learned in grade 11. Okay. Yeah, and this is just to say that we must not forget what we've learned in previous grades. Number 5. minus cos squared 15 degrees minus sine squared 15 degrees. We look at this expression, kind of has those movings of the double angle, but here's the problem. The first term is negative, the second term is also negative. So we call to remembrance the fact that there's factorization that we need to do first here. Okay? And the factorization that we are talking about is we need to take out a what? A highest common factor. The thing is, if the first term of an expression, okay, is negative, we were told that we take out the negative sign as the highest common factor. We take out the what? The negative sign as a HCF. Okay, so yeah, because when we dealing with highest common factor factorization, we take out this highest common factor sign, we take out the highest common factor number, we take out the highest common factor letter or variable. So in this case, the highest common factor sign is negative because the first term is negative. But it's negative what? Negative 1. Okay, that's the highest common factor in number. Highest common factor sign and number. There's no letter, of course. There's no common variable or common trigonometric ratio. Then we're left with what inside? Cos squared 15 degrees plus sine squared 15 degrees. Because if you take out a negative sign, this first term becomes positive, the second term becomes positive. Okay, so this is what they mean by without using a calculator, the steps you need to see very clearly. So then before we do that, we need to be reminded that, of course, addition is commutative. In other words, the way in which you write your terms inside the bracket, if there's addition, doesn't matter. But I write it in such a way that what do I see now? Very clearly, I'm seeing the expression of the square identity that I learned in grade 11. The addition of that square of sine and square of cos gives me positive 1. So therefore my answer is negative 1 times that 1, which is negative 1. Okay, so hopefully it's coming together, guys. You guys can see that this double angle stuff is not too shabby after all, but I need to remember my algebra. Okay, yeah, there's been factorization that I've had to remember, the sign change rule that I've had to remember, and all these other things that I think are not important in trig, but they actually are. Cos squared 22,5 degrees, 2 cos squared 22,5 degrees minus 1. Okay, so what is that equal to? So you can see this is 2 cos squared 22,5 minus 1. This mirrors the same what? The same expression as the double angle of what? Of cos. So therefore this is cos 2 times 22, what? 5 degrees, which gives us what? Cos of 45 degrees. Okay, yeah, and this is grade 12, right? And then what's cos 45 degrees? Cos 45 degrees is equal to what? If I use my calculator, I get root 2 over 2. Okay, so that's straightforward, no problem. Let's look at another one, my grade 12s. And the next one, next double angle. 1 minus 2 sine squared of what? Of 15 degrees. Okay, what do you see here? This is the expansion of the double angle for what? For cos, because this is 1 minus 2 sine squared a. It's like that. So this is cos of what? 15 degrees, which gives you what? Cos of, what's 2 times 15? It's 30 degrees. What's cos 30? So we can quickly use our calculator here, okay? And my trusted people in the comment section, who are always on the money, cos 30 degrees gives you so that's root 3 over 2, right? Yeah. Okay, let's move on. The next one, 1 minus 2 cos squared of 15 degrees. Okay, remember it says calculate without using a calculator the following. 1 minus 2 cos squared 15 degrees. Do you see that, guys? 1 minus 2 cos squared 15 degrees. So once again, what situation do we see here? This is 1 minus. Usually the double angle is 2 cos squared 15 first, followed by negative 1. But it's not the case here, but there's a negative sign in between. So what can we then apply? What procedure can we apply? We can apply the SCR, meaning the sign change rule. What does that mean? We take out a negative sign, then we change the order. 2 cos squared 15 degrees. So, imbongi, you need to be careful. Okay. It's not what you think. You need to first look at this. This is not the correct order for the what? For the double angle of cos. So basically what we do is we apply the sign change rule, which is a form of factorization. We take out a negative sign that allows us to change the order of 2 cos squared 15 minus 1. No, that's fine. Mistakes are, you're allowed to make mistakes as long as it is a good learning curve for you. Okay, because I also make mistakes, okay? Then this 2 cos squared 15 minus 1. Now this is the double angle. So it's a negative cos 2 of 15 degrees, which is a negative cos of 30 degrees. Now we can apply that negative sign. We know that's the negative, what's cos 30 degrees? It's root 3 over 2. What's minus times root 3 over 2 gives us a negative root 3 over 2. Okay. Yeah. So guys, let's be very careful of this. We always need to go back to our formula sheet and always ask, is this the order of what we know? Because if it's not, then we need to go and actually make sure that we do something. Okay, remember the sign change rule is simply a way of factorizing. So you guys are seeing the advent of factorization when it comes to certain problems that have to do with these double angles. Okay, all right. So I hope you guys can see these skills that you need to have in order to be able to successfully answer certain questions where this trig is concerned. Okay. Let's move on to the next one. 2 sine squared 15 degrees minus 1. Look at this one. 2 sine squared 15 minus 1. So you suppose without using a calculator, you need to actually write this. You need to calculate the following. So 2 sine squared 15 minus 1. If you look at this, you go to your formula sheet, you check this out, the double angle expression. Is there something that says 2 sine squared a minus 1? No, there isn't. The order is not correct because there's a minus sign, but we would like the order to be correct. So that means we need to apply the what? The sign change rule. Sign change rule says what? You take out a negative sign that allows you to then change the order inside the bracket. Okay, so I'm sure now you can see that if you take the negative and you multiply with 1, you get back that negative 1. Take the negative, you multiply with the negatives, sine squared 15, you get back the positive sine squared 15. So this hasn't changed anything. It's just that now we can see what's in the bracket is the double angle. So now you can write the double angle, cos of 2 times 15 degrees. Okay, then we can go ahead and write cos of 30 degrees, which we know if we use our calculator, what's cos 30? That's a root 3 over 2. And then it's a negative root 3 over 2. Remember guys, like I said, we can't use the calculator from the beginning. This thing said without using a calculator, we need to find this. So that means we need to show our steps, okay, and then obviously get to the answer. Okay, so I hope that's clear for all of us, how we were able to get to that beautiful answer. Okay, so hopefully we're ready for the next one. And the next one is what we have here. Without using a calculator, we need to find what sine 15 times cos 15 is. Now, at first glance, when we look at this, we're like, what in the world is happening here? Okay, what we would expect to have is a 2 times the sine 15 times the cos 15, but we don't have that. Rather, what we know is that there is a 1 here. 1 sine 15 cos 15. So then what do we actually now do? Okay, what do we now do? Sine 15 times cos 15. There's a 1 there. But this kind of mirrors the double angle for sine, but we don't have 2. So we can't force and just write 2 here. It can't happen. So then there's something that we need to take into consideration, and this is what we refer to here as something that we refer to as the multiplicative inverse. All right. We would like to have a coefficient of 2 here so that we can write the double angle, but how do we produce this expression in such a way that we can have a coefficient of 2 while still retaining the identity of having 1 here? So what we do, guys, right, and this is something you need to standard apply. Let's say we have sine A cos A. We know that there's a 1 here. We apply something called the multiplicative inverse. Okay, this here can be written as a half times 2. Now, I'm sure all of you know that if you take a half, you multiply it by 2, what do you get? Don't you get 1? Don't you guys? We do, right? So hopefully all of you can see that a half times 2 is 1. Now in grade 8 and 9, you guys learned about what we refer to as the multiplicative inverse. A multiplicative inverse simply means, that when you take a certain number, let's say you have the number, let's just take another rough paper here. You have the number 7. The multiplicative inverse of 7 is what? Is 1 over 7. In other words, the multiplicative inverse, the intention of the multiplicative inverse is so that we can get the number 1. Okay, so 7, the multiplicative inverse of 7 is 1 over 7. So when you multiply 7 times 1 over 7, you get 1. 8, what is the multiplicative inverse of 8? It is 1 over 8. So 8 times 1 over 8 will give you 1. Multiplicative inverse of 3. What's the multiplicative inverse of 3? It is 1 over 3. And that is because you get 1 whenever you multiply 3 with 1 over 3. Rightfully so, if I have negative 1 over 7, what is the multiplicative inverse of negative 1 over 7? It is negative 7 over 1. And deliberately we're saying negative because finally a negative times a negative gives us a positive, and obviously 1 over 7 times 7 over 1 gives us 1. So, because this is something we learned in earlier grades, we know we would like to have 2 as the coefficient of sine 15 cos 15. So we make it such that the situation becomes like that by using the multiplicative inverse. So if I take 1, like convert it to half times 2, that allows me to put this 2 in brackets. Doesn't change anything still, because remember, brackets mean multiply. And then I can write the sine A cos A in brackets. Did I change anything to this expression? Okay, not completely, because remember, this still retains its identity. Half times 2 will still give me back the 1, and I still have sine A times cos A. But I do this because I want to convert this to the double angle, which is, I can see it kind of is something like that. But in order to make it so, I use the multiplicative inverse, okay, so that I can ensure that that does happen. And then what I can then write is half outside, and then sine 2 sine A cos A is the double angle of sine. So I can write sine 2A. And the reverse is true. Okay, so let's come back here. You were given sine 15 times cos 15. I need to, without using a calculator, I need to calculate what this is. So I'm going to take this 1, which I cannot see. I know it's there. And I'm going to say half. Then I'm going to say bracket, because brackets mean multiply. 2 sine 15 times cos of 15 degrees. So hopefully all of you understand why I did what I did here. Okay. Then half, remember this here now is the double angle of what? Of sine. So I'm going to say sine of 2 times 15 degrees. And then half bracket, what sine 2 times 15 gives me? Sine of 30 degrees. And then I conclude half sine of 30. If I use my calculator, I can use my calculator now, sine of 30 degrees, so that I can get the ratio of what sine of 30 is. So the answer is 1 over 2. And then obviously a half times half gives me a quarter. Okay, guys, do you see how smooth this all becomes? And this multiplicative inverse understanding is very important, because many people cannot use this multiplicative inverse. Now, this is a grade 8 concept, grade 9 concept. When you solve equations, all right, whenever you have this thing here, like for instance, you have 2x is equal to 4 and you need to solve for x, what you do when you're dividing by 2 both sides is you are using the multiplicative inverse to ensure that you get the coefficient, which is 1, and then x is equal to 2. Remember, this is actually the use of the multiplicative inverse. So this idea, or this concept of multiplicative inverse, we've been using in grade 8, 9, 10, 11. So now that you are in grade 12, like, it should not even be a question as to whether you understand why we are doing what we are doing, why we are saying half times 2, in order to actually still retain the integrity of the expression, that being 1. Okay, and then that allows you to use the double angle. You then write this as sine 2 times 15 degrees, which is sine 30 degrees, which is a half, and then obviously a half times half is a quarter. Okay, right? So hopefully it's like, wow, I see, sir, and I hope you do. We just use the multiplicative inverse to basically get our way in that situation. Let's look at this situation. What about this one? 2 cos squared 22,5 degrees. We look at this, we're like, okay, and then what happens here? Okay, double angle expression. We're looking at this is 2 cos squared 22,5, and we're like, isha, but there's no reduction of the double angle that will lead us to a place where we can actually simplify this without using our calculator. So it then stands to reason that if I look at this, I see 2 cos squared 22.5 degrees. If only it was followed by this 2 cos squared 22.5 degrees, if only it was followed by -1, then I would basically know that this is the double angle. But the thing is, I don't have -1. So what I do, guys, is I'm going to say -1 and I'm going to say +1 as well. What? Hey, Bo, sir, what did you just do? So here I used something called the additive inverse. Yo, guys, we're dropping some serious, they would say I'm cooking. It's the serious cooking that's happening here. So here's another grade 8 and 9 concept. Okay, we look at 2 cos squared 22.5. We look at our double angle identities. Okay, and we can see that that's 2 cos squared 22.5 degrees. This here is similar. We it's kind of like giving those vibes, all right, of the double angle. But then there is no -1 here. Okay, so I use the additive inverse. Okay, so I put in the -1, but then I cancel that -1 by +1. So this is why I'm saying this part is what we call the additive inverse. Guys, what is -1 + 1? Doesn't that give us 0? It does. And doesn't this actually not change at all what I had in the original expression? It doesn't. But it helps me with my situation, because now, looky what I got here. Looky what I got here. Looky what I got here. The first two terms are the double angle expression. So now I'm going to substitute the double angle expression of cos 2 of what? 22.5 degrees. Okay. The orange part is my cos of 22.5 degrees. 2 times 22.5 degrees. And then what follows? +1. That +1 there. This +1. That follows thereafter. Now I can go ahead and write cos 22.5, that's 45 degrees +1. And then, of course, what's cos 45 degrees? Guys, cos 45 degrees, of course, is √2/2 +1. So I can add these fractions. It goes without saying that it's going to be √2. I can just use my calculator here. It's going to be √2 + 2/2. Okay, you can use your calculator at this stage. You can just punch this into your calculator. You'll get √2 + 2/2. Some of you are asking, why am I going live when you're about to go to school? Remember, I've been up. Okay, it's been declared that my grade 12 sessions, I'm doing them at 5 a.m. in the morning up until 6:30. So in 13 minutes time, the live will be done. All right, but like I said, if you've missed it, I'll be uploading all of this for the grade 12s onto my YouTube channel. You can always find that in my YouTube channel. You can watch the session that you may have missed and be able to catch up at your own time. So remember, the link for the YouTube channel is in my bio. The YouTube link, not the WhatsApp channel, please. The YouTube link. Please, guys, subscribe. Make yourself part of the community so that we can continue to push. I've already done 2 sessions already on compound angles, all right? And today I'm doing a 3rd session, which is now on double angles. And I will continue in that same vein tomorrow as well, same time, 5 a.m. and the day after. And so it goes. I hope you guys can sort of like be patient with me where that is concerned. And yeah, okay. Yeah. So I have said 5 a.m. in the mornings is the grade 12 slot. Trying to teach you guys the value of discipline and waking up early in the morning. If you can get that down, you guys will be winners. Okay, so I hope you guys are really starting to see this thing. There's nothing much in this thing, guys. Nothing much in this thing. Okay, I hope you are starting to see that there's nothing much in this thing. Okay, let's do one last one. You can, whatever helps you guys, whatever it is that you are talking. I don't know if I'm hearing you correctly. Can I print the screen, sir? I don't know what do you mean by that, but yeah, whatever helps you, whatever tickles your fancy. Okay. Half minus sine squared 15. So let's look at this particular question. Half minus sine squared of 15 degrees. Okay. So if you look at this one, half minus sine squared 15 degrees, okay, it kind of gives you those vibes of like half minus sine squared 15 degrees. If you had the double angle, it would be cool, but you can see we don't have that here. Okay, yeah, so obviously, like, there are things that ought to be done. So I'm actually going to leave this with you as a challenge question. All right, just smack bang at the end. Okay, so when I reopen my live next week, okay, I will actually then do this. No, not next week. When I reopen my live tomorrow, I'll do this question. Let me leave this for you as a challenge question. You can answer it as we go along. I just want to conclude with the following sort of like problems which refer to simplification, so that we can see the application simplification where double angles and compound angles are concerned. So I'll leave this for you guys to do. Then let's look at this very quickly before I end the live. Simplify the following. So let's say we were given sine of 2x over cos of 2 cos squared x. And we are required to simplify this. Okay. So when we're simplifying, guys, we always take into consideration the following. We simplify, we factorize, we use our identities. We simplify, we factorize, we use our identities. So simplification, or the simplification of identities, requires a three-part strategy, which is, first you simplify, all right? You look at, is there anything you could simplify in the particular expression? Then, if not, you look at factorization. Okay, is there anything to factorize? If not, you look at identity. Okay, yeah. So you're always moving in this format. Simplify. If there's no simplification, you move on to factorization. If there's no factorization, you move on to identity. Okay, let's say you simplify and there is simplification to be done and you are done with it. And when you look at the problem after simplification, you're like, what more can I do? Then you must move on to the next strategy, which is to factorize. If there's no factorization, then you move on to the next strategy, which is you check if there's any identity, whether that be square identity or quotient identity as per the grade 11 syllabus, or that be your double angle and compound angle identities. So this is what you are constantly looking at, to simplify, factorize, or to express as the identity. So if you look at this problem, for instance, sine of 2x, this is the double angle of sine 2x. So how do we expand it? So if we look at this, is there any simplification that can be done in the question? No. Is there any factorization that can be done? No. Is there any identity that I could actually express? Yes. So the first key strategy is the expression of the identity. Okay, so I just applied identity, my double angle expression identity, because simplification there was nothing, factorization there was nothing, identity yes. Now that I'm done, that identity has been done, I go back to the first strategy, which is to simplify. I relook at the question after applying identity. I go back to the first strategy. Is there any simplification that can take place here? Yes. The relationship at the top is multiply. The line means divide. There's one term in the numerator. this cos x and this cos squared x, there can be a cancellation that can happen. If I cancel one cos x here and I cancel another cos x here, what gets left behind? So if I cancel, guys, I'm just going to use a different sort of like pen so that I can actually make the point clear. I'm left with 1 here. Here I'm left with a cos x, one of them. Okay. Then there's the 2 and the 2. 2 divided by 2, I'm left with 1, and I'm left with 1 there. So my final answer then is what? At the top, I have sine x, that's times the 1. Obviously, 1 times sine x times 1 gives me sine x at the top. At the bottom, the 2 and the 2 also cancel, so I'm left with a single cos x. That's what my simplification led me to get, sine x over cos x. So simplification is done. Okay, then can I factorize? No. Is there an identity I could use to simplify this further? Yes. What's sine x over cos x? It is the quotient identity, which is tan x. Done. Identity. Guys, do you see this movement between simplify, factorize, identity, simplify, factorize, identity? And this is the strategy that you apply when you are simplifying. Okay, so in your head there is some sort of movement or some sort of like approach that you are taking when you are simplifying any complex fraction that involves trigonometric ratios. You are constantly moving between simplification, factorization, the identity. And if you guys do that, I don't care what question they give you, you are always going to be killing it. Okay, let's look at another one. Cos 2 theta over sine theta plus cos theta. Now, also, when you look at a problem, guys, before you even apply this SFI, be aware of what you have. You look at the top, you're like, oh, sine 2x. You look at the bottom, it's cos 2 cos squared x. So obviously there's something that can be done here. All right. Yeah. And here, you don't have to complicate your life and try and express this as your square identity, the other form, because it's going to complicate life. You're going to make life complicated for yourself. You know, when the relationship is multiply and divide, cancellation is easy to be done. So here we have cos 2 theta over sine theta plus cos theta. So once again, SFI. So let's first look at the situation. We can see the sine theta plus cos theta at the numerator, at the denominator, sorry. The numerator has cos 2 theta. This here is the double angle cos 2 theta. Okay, and there's 3 choices that I can choose from, but there's a preferred choice. Like, I mean, you're not going to just write any of those expressed identities. You're going to choose the one that is most appropriate for the situation. Okay, so 1, simplification, no simplification. Factorization, no factorization can be done here. Identity, yes. At the top, identity. Which one? You can't just choose any one. You have 3 choices, guys, to make. 3 important choices. You can either choose this one, or you can choose that one, or you can choose that one. The one that you choose will help you in the situation. The wrong one that you choose will complicate your life. Okay? Yeah. This is like if you are making a choice of your wife, your future wife or your future husband. There's a choice, maybe all 3 may be right, but there's the one that works for the situation. So you must always be vigilant, and I'm giving advice to some of you who are still here to make those choices in the future. There's the one that is right for the situation. So is it the first one? Is it the second one? Is it the third one? Because this double angle can be expressed as either one of the 3. So if you are looking at the situation around the problem, which one is most appropriate, okay, for this situation? It is very clear that the first one is most appropriate for the situation. So we are going to say cos of squared theta minus sine squared theta over sine theta plus cos theta. Some of you are looking at this and you're like, Aibo, why did this guy choose that one? Why didn't he choose the other one? It's because, like I said, I'm choosing the expression of the identity that is right for the situation. I've looked at the denominator. I can see, hey, this one. The one that will be right for the situation is that one. Why? Because, like I said, in my three-part strategy, I've just applied now the identity. I'm done with identity, so then I move. Is there any simplification that can be done? No. Factorization. Factorization at the top. No wonder I chose this one. Factorization at the top. Grade 10 syllabus, grade 9 syllabus, what type of factorization do we have here? This is a difference of two perfect squares. So what do I do when I'm factorizing with a difference of two perfect squares? Cos theta here, cos theta there. Plus, minus, sine theta here, sine theta there. The reason why we do this is because we can see there's a factorization strategy that can be applied in the numerator, which is why I chose this one. So obviously I need to have an idea of the end in my mind when I do the questions. I can't just jump in and just do whatever I want and there's no particular order and common sense. There needs to be common sense that informs my decision. All right, and I'm looking at the situation around what I'm doing, you see, which is why I took this option, not the other two options. This option would have been a very fatal one for myself if I had chosen this one. This option would have also been fatal for me. So that's why this option works, because I know my three-part strategy that I'm applying, and therefore I choose the most appropriate choice. So this one works. Remember, when you are factorizing a difference of two perfect squares, guys, you take the square root of the first term. That will inform your first term in your brackets. You take the square root of the last term. That will inform the choice of your last term in each bracket. And then each bracket must have plus and minus. Okay. Which paper? Which paper are you talking about? You're talking about this one? Or are you talking about my formula sheet paper? Because remember, the formula sheet is with you. You know the formula sheet for your double angles. You should know those. Okay. Then let's continue, because factorization has now been applied. Okay. And see, look at that. Sine theta plus cos theta. Now what I do is I put brackets around my sine theta plus cos theta, which makes this one term in the denominator. Okay. Got done with factorization. I move on to my next part strategy, identity. Is there any identity here that can be done? No. I'm done with identity. I move back to my first strategy. Is there any simplification? Yes. This here, cos theta plus sine theta, is the same thing as sine theta plus cos theta. Just like 1 plus 2 is the same thing as 2 plus 1. They both give me the same answer, right? So, goodbye. Cancel. What's left there? 1 and 1. What is left? My answer is cos theta minus sine theta. It's in the numerator, right? So that's all over 1, but then obviously I know, guys, that is basically none other than cos theta minus sine theta, and that's where I end. Okay. Good, beautiful people. I'm going to leave you right there, but I'm going to leave you some challenge questions to do, or game challenge questions to do, so that you can also participate. Okay, because simplification was used, okay, here, so that I can be able to get the answer. So I'm always moving between these three-part strategies, guys. Okay, now I'm going to give you your own challenge questions. You can do them, and then I will open the session tomorrow morning at 5 with these corrections for these problems. So you can also simplify here, guys. All right, maybe you're gonna feel like, hey, it's a bit more complex, but yeah, why not? Okay, why not? So tomorrow when I open my live, I'm going to start by doing corrections for these problems, okay, including the other one that I actually gave you earlier on, and I said you must also do that one. I will open the live session with those questions. Okay, so these are the 3 problems. Sorry, forgive me for this. Yeah, that's cos to the power 4x minus sine to the power 4x. So these are the 3 problems. 1 minus cos 2a over 1 minus cos squared a. Cos alpha minus sine alpha over 2 sine alpha minus 1. This is the whole thing squared. And then cos 2x over cos to the power 4x minus sine to the power 4x. We'll open our live with those 2 and then calculate without using a calculator. The following, yes, this is metric work, guys. This is metric work all the way. This is metric work. It's not grade 11. Metric. So I do only lives for metric in the morning. I don't do lives for any other grade. Okay. Calculate without using a calculator. Sine 39 degrees over sine 13 minus cos 39 over cos 13. So I'll open my live and do these corrections for 1, 2, 3, which is simplification questions, and then calculate without using a calculator this. But you guys should go ahead and attempt them first, and then tomorrow morning at 5 a.m. guys. So I'm doing the live session from 5 a.m. up until 6:30. Then I go to work. I have to rush now. I have to leave you guys. Love and leave you. Thank you so much for joining. Kayla, thank you so much for the rose. I really appreciate it. Guys, I really appreciate the gifts. You must know that I appreciate them a lot. You could say it kind of also serves as sort of like some sort of incentive for me for doing what I'm doing, even though I'm not doing it primarily for that. But I'm not gonna lie, guys, I mean, it does buy my heart, and I really appreciate it. So thank you so much. Have a good day. I hope you guys will have a great one. If you're going to school, please drive safely. If you're taking public transport, please be safe. Get there in one piece. If it so happens that you're actually in a car and you are listening to me teach mathematics and on your way to school, that's amazing. You are a phenomenal person. If you have big goals for this year and you want to really do very well in your mathematics, your dreams are valid, your goals are valid. You will do it. I think there's nothing definitely impossible. You can definitely do it. And whatever you're going through, whether that be something that has to do with personal life, home situation, it may be that you are experiencing a lot of opposition. It may come from people that you love. You are in matric and you're like thinking there's no support, no one is supporting me. Like it just feels like I'm all alone in this battle. Like I'm the only one that seems to recognize the importance of this year. Like everybody else is just not really for me. It seems like everybody's against me. Just know that you are not alone. You're not alone. You're not alone. You're definitely not alone. And yeah, we'll be here to support you with these live sessions in the morning. And let's just do this, guys. Let's do the most. I think we can. We can definitely do it. I'll see you guys tomorrow morning, same time. So like I said, live sessions start at 5 a.m. guys. I'll try to also wake up. I didn't make the 5 a.m. myself. I actually started this live like 5:20. So yeah, but then I will be uploading this session on my YouTube channel. You can go to my bio. The link is in my bio. MathsIsAGame 5 to 7. That's the YouTube channel. I have uploaded the first 2 sessions I did on compound angles, and I'll be uploading this double angle session as well onto that YouTube channel so that you guys can watch it at your own time. It's very raw. Nothing. You can see, guys. I mean, I'm moving a lot. Like there's this type of thing that's happening, the conversation in between, it's unedited, it's raw, it's just as it is. So yeah, hopefully you can really bear that as well. Cheers, thank you so much. Lots of love, guys. Have a good day. Remember, maths is a game. We can play it. We can all play it. Let's play it.